Continuing lesson 2.9, which is analyzing linear equations, y equals mx plus b. Again, a quick refresher here. Y equals mx plus b. We talked about the m is representing the slope, which we've already talked about before, and the b is representing the y-intercept. One thing we haven't talked about at this point is it's plus b. So anytime if there was a minus something, you can add the opposite, and then you would just have a negative y-intercept is what that would be. And actually we have that case right here on example 2. So example 2, a saltwater solution is cooled to -6 degrees Celsius. During an experiment, the mixture is heated at a steady rate. Write an equation to represent the temperature y after x minutes. So you can see the picture here from this. They want us to write an equation. So what we're doing, we're looking for two things. We're looking for what the slope is and what the y-intercept is. Y-intercept is going to be the easier thing to find. Okay, y-intercept, we're just looking where does it hit the y-axis, and again that would be at -6, which they kind of told you. They said it's cooled to -6 and then it's heated up from there. We'll not do this like the book's doing. We'll do our y and then our x. So finding another point on the line, if you wanted to, you could actually go right here, would be another point. So you could say we'll go up 2 and over 1. So change in y over change in x. 2 over 1, which is the same as 2. And so slope would be 2. And then it's just a matter of substituting your slope and your y-intercept into that y equals mx plus b equation. The book just picked different points, and that's okay. As long as you find a point that hits exactly, they would be then going up 6 and over 3. 6 divided by 3 would still be 2, so that's still the same slope. Alright, so if our y-intercept is -6, our slope is 2. Again, we're just substituting into this equation. So slope is 2, so we just put a 2 in place of the m. Y-intercept is -6. You could either put it this way like the book has, y equals 2x minus 6, or if you put y equals 2x plus -6, that would work also. Those are both equivalent equations there. So either one would be fine. In some cases, they are going to give you an equation and they're going to ask you to graph it. Easiest way to graph an equation, first step would be to graph the y-intercept. After you graph the y-intercept, then you can use the slope to find another point starting from the y-intercept. So start at your y-intercept, use your slope, and figure out, how many do I need to go up and over or down and over. Or another option you have, besides doing those two things, your other option is just to choose 3 points and make an XY chart. If there's no fractions involved, if there's no fraction coefficients in our equation, you can just use 0, 1, and 2 for your x values. Substitute those, see what you get. One nice thing about doing this is if you get 3 points and you can get all 3 points to line up with each other, that's a pretty good indicator that you've graphed this correctly. These should be linear equations for you guys right now. They should be making straight lines. So this is kind of a little bit safer approach, I would say, because that gives you 3 points, and then with 3 points you know if the points are lining up or not. If they're not lining up, you made a mistake, then you need to go back and rework that process. The other first 2 steps, it could potentially be quicker, but you don't have the double checks there. You don't have a way of necessarily checking because you've only got 2 points. Any 2 points make a line, whether it's the right line or not. So just be careful. nothing wrong with doing those first two steps I mentioned, but you just have to make sure that you have the 2 points you want for sure, because we don't have a way of checking to make sure that we've done that correctly or not. In a case where you did have a fraction coefficient, so let's say, for example, our equation was y equals 3/5 x minus 2. If you get in a situation like that, I always like putting a 0 in for x. Put in a 0 because, you know, a number times 0 is always 0. What we would want to do at that point is look at your denominator, and actually if you use your denominator as another x value, so in this case our denominator is 5, I would use 5 as another x value, and then the next multiple of that denominator. So in this case, next multiple of 5 would be 10. Okay, by doing those, that's going to eliminate the fraction when we work it out, because 3/5 times 5, you guys know when you're multiplying, you have the option of reducing factors. Okay, or you can just multiply that across. That'd be 15 over 5. 15 divided by 5 is 3. Same idea if we have 10. If we would be doing this 3/5 times 10, you know, again, you could reduce these by 5 since we're multiplying, and you get 6, or multiply across, you get 30 divided by 5, which is 6. So on example 3, they ask us to graph this equation y equals negative 4x plus 3. So the book's doing it those first two steps that I mentioned. So first step is they graph the y-intercept. So we can see from our equation y-intercept is 3. So they graph this point 0, 3. From that point we can use the slope. Slope is negative 4, which is like negative 4 over 1. And remember, slope is a change in y over change in x. So if my slope's negative 4 from that point 0, 3, from my y-intercept, I can use that slope to find another point on the line. In other words, change in y is negative 4, we can go down 4. So if I'm at 3 and I go down 4, that'll take me to negative 1. Change in x is 1, so we go over 1, and that would take us to this point 1, negative 1. And then that's enough, technically 2 points. We can draw a line that goes through those points, and we would be good. Okay. The other option I mentioned to you is that we can make a table. So if you have a hard time doing those things that the book mentioned, or if you just want a little bit of a safer approach to working this out, you can use a table. This one didn't have any fractions to start with, so you should be good to use just 0, 1, and 2 for your x values. And it's just a matter of substituting in the x values that we're using. Okay, since y equals negative 4x plus 3, when we work this out, negative 4x plus 3, we work that out. That is what our y value is, because it was y equals that. So if we do this for a 0, negative 4 times 0 is 0, and then 0 plus 3 would be 3. So 0, 3, which was our y-intercept we talked about. If you put in a 1 for x, would be negative 4 times 1 is negative 4 plus 3, negative 4 plus 3, which is negative 1. And if you put a 2 in place of x, negative 4 times 2 is negative 8, and negative 8 plus 3 would be negative 5. So again, nice thing about this is we've got actually 3 points to double check and make sure that we've done this correctly. The graph in the book, 2, negative 5 actually would be just off the graph, just below the graph there, but you can see that looks like it is probably going to hit at that point of 2, -5 as well. And just to make sure everybody's understanding here, when we're doing the table, when we put in a 0 for x and we got 3 for y, what that means is our graph is going through the point 0, 3. We put a 1 in, we got -1. Our graph's going through the point 1, -1. Okay, so we would be graphing these points as we find this information out. We would graph the point 0, 3. We would graph the point 1, -1. We would graph the point 2, -5. And again, at this point, they're going to give you a linear equation. So these points should be in a straight line with each other. If they're not, we made a mistake. So again, 3 points, if I can get them to line up, I should be in good shape. Then that's probably the correct graph for that line. And again, after you graph the points, go a little bit past those end points and put arrows on both ends, unless it's like a real life situation where it doesn't make sense for negative numbers or something like that. So the try it asks on part A, what is an equation for the line shown? This is more of stuff that we were doing at the beginning of the lesson. Find the equation, so we have to know two things. We have to know what the slope is, and we have to know what the y-intercept is. So one of the easier things for us to do, probably starting out, would be to look for the y-intercept. That's where it hits the y-axis. So our y-intercept here would be 2. And then the only other question is for us to figure out what our slope is. So to find that slope, I need to have 2 points. I already have 1 point, 0, 2, which was our y-intercept. We need to find another point that hits solid on our line here. I like to go to the next point that's just to the right of my y-intercept. You don't have to do that, but just kind of what I like to do. And again, we do know this is going to be a negative slope. Remember, slope, it's change in y over change in x. So we want to think about, if I'm starting at the point 0, 2, how do I get from 0, 2 to the point 2, 1? So what we would need to do, we would need to go down 1, which is like a -1, is our change in y. Our x, we're going over 2. This is nice on this graph because they are just going by 1, so you can literally count the squares. Okay, down 1 over 2, so our slope would be -1/2. So that means my equation would be y equals -1/2 x plus 2. If you wanted to, for the slope, to show your work there, for the y values, we were going from the point 0, 2 to the point 2, 1. So you could say, I'm taking 1 minus 2, and then I'm taking 2 minus 0, and that would be, 1 minus 2, and then 2 minus 0. That's how we could get those numbers, -1 over 2, if you wanted to show that out. Part B is more like what we've been talking about recently. They want us to graph the line with this equation, y equals 1/3 x minus 5. And they are jumping us right into this. They're not going to give us any kind of an easy equation necessarily to graph right away. This one's not too bad as long as we know what we're doing. But like we talked about earlier, you could use the y-intercept and the slope and graph it that way. Probably a safer way would be to make a table. And then we want to pick some points. Again, if we can pick 3 points is good. Only 2 points doesn't give you a double check to make sure you're doing it right. So if you do a table, I'd recommend that you pick 3 points out. So if you get to pick whichever numbers you want to, easiest as far as graphing especially is going to be picking things that are not going to give you fractions. 0 I'm always going to pick as an x value. And then like we talked about earlier, since my denominator is 3, pick that as one of your x values, and then the next multiple of 3 is 6. Those are going to be numbers that are going to be easier for us to work with. That's not going to give us fractions when we go to graph this. So then you can just substitute this in. 1/3 times 0 is 0. And then we've got 0 minus 5. If you want to add the opposite, you can. That's going to be negative 5. If you put a 3 in, that's like 3 over 1. So 1/3 times 3 over 1, that would be 3/3, which is the same as 1. So that's 1 minus 5. Add the opposite if you want, is going to be negative 4. And then if you put a 6 in for x, 1/3 times 6 is like 6 over 1. So that'd be 6 over 3. 6 divided by 3 is 2. So we've got 2 minus 5. And again, if you add the opposite, that would be negative 3. So this should give us 3 points that are going to line up with each other when we go to graph them. Again, if they don't line up with each other, we made a mistake when we worked it out, and then we'll just have to go back and rework out these parts. So at this point, we would graph those points. Starting out, we've got 0, negative 5. And then we've got 3, negative 4. And 6, negative 3. Anytime if you're doing these graphs and your points are not on the graph that they've given you, you can use graph paper to figure that out. Obviously, it's a good idea to try to work with the table that's been given to you, though, because if you're doing this like on your iLearn test, then you can't just say, no, I'm not going to use your graph. You don't really have an option at that point. So we talked about with our equation here, the slope is 1/3. Looking at the graph does look like it has a positive slope. Also, this end part here, if you want to add the opposite, that would be plus negative 5. Negative 5 is our y-intercept, and I can see that here. If you wanted to do the other method we talked about, you could start with graphing. I've got as this blue point here, that's our y-intercept of negative 5, and then you could say my slope is 1/3. So from that point, you could say change in y is 1, change in x is 3, and that will give you another point, and then you can just connect those, and that's technically your line. If you want to get one more point doing it that way, go up 1 and over 3 again, and that'll get you to another point on the line. Okay, so either way that you want to do those, again, the table is probably a little bit safer way of doing this, though. So if you look at the do you understand number 2, donations by a restaurant to a certain charity Y will be 2/5 of its profits X plus $50. How can you determine the equation in slope-intercept form that shows the relationship between X and Y without graphing the line? So without graphing the line, they want us to try to come up with an equation. Okay, so we want to think about y equals mx plus b. We want to think about what our slope is and what our y-intercept is here. So it says the donations will be 2/5 of its profits. Remember, of usually means multiply, so 2/5 times the profits is x. So 2/5 times x and then plus $50. So y equals 2/5 x plus 50 would be our equation. Number 3, Priya will graph a line with the equation y equals 3/4 x minus 4. She wants to know what the line will look like before she graphs the line. Describe the line Priya will draw, including the quadrants the line will pass through. So when we go to graph this, knowing what we do, y equals mx plus b, this is going to have a slope of 3/4, which is positive, so positive slope. Y-intercept is -4. It's going to start in quadrant 3, then go to quadrant 4 and quadrant 1. The quadrant part, don't worry about that so much as thinking about that we know what the slope and the y-intercept are going to be.